Right, so you saw that within the Kubernetes cluster, we do have the master node. Now, the master node contains what is known as the control plane. The control plane is made of several components, and they are the API server, the scheduler, cluster store, controller manager, cloud manager, which talks to the underlying cloud provider API, whether it's AWS, Google Cloud, Azure, so on and so forth. And all of these components within the master node, they communicate via the API server. And also we do have the worker nodes, but these are outside, right? So the master, it's a node, right? So a VM that contains all of these components right here. And then we have the individual worker nodes, which I'm going to explain what they are in a second. So now let's start by understanding what each of these components inside of the master node do. So let's start with the API server. Now the API server is the front end to the Kubernetes control plane. All communications go through the API server. This includes external and internal, and it exposes a RESTful API on port 443. And also, in order for you to talk to the API, authentication and authorization checks are performed. So in essence, we have the API server. If you are talking externally using kubectl client, which you're going to learn later. So here I'm saying kubectl apply and then F for a file, and this is a YAML manifest that I'm going to teach you as well. So this file is actually sent to the API server, and also internal communication goes via the API server. So you can see that this is a very important component. Next, we have the cluster store, where this really contains all of the state for our application. So it stores the configuration and state, and currently Kubernetes uses etcd, which is a distributed key value data store, and etcd is the single source of truth. So it's our database, right? So like any other application that you build, the database contains the source of truth. So here, if I use kubectl or kubectl, which you're going to learn in a second. So if, for example, you want to apply a YAML manifest, then that goes through the API server all the way to the etcd store. So etcd contains the configuration for our entire state. So in here, I'm in the official website for etcd, and you can see that it's a distributed reliable key value store for most critical data and distributed system. You can see that the features, it's simple interface. It has a key value storage. You can see that it stores the data really organized in directories as in the standard file system. And here it watches for changes on specific directories, and it also reacts to changes. And you'll see why this is important in a second. So if I scroll down, you can see that the adopters, so here Kubernetes is the backend for service discovery and stores cluster state and configuration. So this is really important. This is really important. And also you can see that etcd is written in Go, which has excellent cross-platform support, small binaries, and great community behind it. And communication between etcd machines is handled by the Raft consensus algorithm. So you're going to learn about this later in this course, but I just wanted to show you that etcd is really, really nice, and it's been adopted by quite a lot of organizations and projects, and you should be aware and familiar with it. Now, let me go back to the slides and learn about the scheduler. So the scheduler watches for new workloads, pods, and assigns them to a node based on several scheduling factors. Is the node healthy? Does it have enough resources? Is the port available? Affinity and anti-affinity rules, and other important factors. So you can see that it's a really important component. Next, we have the controller manager. So this is a daemon that manages the control loop. So basically, it's a controller of controllers. In Kubernetes, we have a bunch of controllers, And let me just show you the node controller. And what this controller does is whenever the current state doesn't match the desired state, then it reacts to those changes. In our example here, we are setting the desired state equals to 1 node. And this is not the actual way to do it, but this is just an example. And if we have 1 node, then if this node dies, right? So if this node has a problem, maybe it has a disk failure, or it ran out of memory, or any other factor. So if this node dies, then the node controller is responsible for bringing another node. So you see here, so this is the purpose of the node controller. We have other controllers such as the replica set, which is responsible for ensuring that we have the correct number of pods running. We have the endpoint controller, which assigns pods to services, namespace, service accounts, and others. And to put it this way, what the controller manager does, it simply watches the API server for changes. And the goal is to watch for any changes that does not match our desired state. So we have a desired state and we have the current state. If the desire doesn't match the current state, then the appropriate controller kicks in to try and match the desired state. So a controller is simply a watch loop. We also have the Cloud Controller Manager, and the Cloud Controller Manager is responsible to interact with the underlying cloud provider, such as AWS, Azure, or Google Cloud. So in this example here, we have a bit of configuration, and you're going to learn about all of this and what it means. But basically, this configuration right here, or this manifest, I've called ingress.yaml, contains an ingress, and this gives us a load balancer. Now, first, this request goes through the API, and then that gets stored, and then the Cloud Controller Manager kicks in. Now, depending whether you are running Kubernetes on AWS, for example, then it creates the load balancer, which is an ALB, Application Load Balancer. If you're running within Azure, then it creates the equivalent, but using the Azure Cloud API. The same for Google Cloud. So you see that the Cloud Controller Manager is responsible for interacting with the underlying cloud API provider. So you've seen how it does it for load balancers, but it's the same with storage or instances. So these are VMs. And to be honest, these are all of the components for the master node that makes up the control plane. So the master, in a nutshell, runs all clusters control plane services. And as I said before, it's the brains where control and decisions are made. And there we go. You now know about the control plane and master node. Next, let's go ahead and learn about the worker nodes.